Well, oh shoot, hold on, give me a sec. Any questions? So I know Jessica said she like just needs help in general, but any other questions?
Yeah, I just need help with
Okay.
like yeah.
All right. With the unit circle stuff, right?
Yes.
All right, cool. All right, I'm just gonna kind of start like explaining it in my own terms. So so the way I look at it, do we all feel good about the general like graphing part from last week where like the graph now becomes degrees? Does this all look familiar and okay?
Yeah,
Yes.
it makes sense.
Okay, cool. So this is so the better you understand like this, right? So now now when we graph like angles and triangles and stuff, um you think of it as a clock, right? So you start at 0 and the only difference is this clock goes counterclockwise. So if we want to go to like, I don't know, like 200, right? We rotate all the way around until we get to somewhere around 200. So the better you understand this, the easier it is to know the unit circle. Because the main thing about the unit circle is just now you're using this unit called radians. Okay, so radians is just a unit that uses pi. So pi is like the big factor there. So what you do instead is instead of now doing degrees, right? So I'll write the radians next to it. So um, yeah, instead of doing degrees, now you're writing radius. So I'll do this in yellow, right? So now this is 0 because the starting part is always 0, right? 0 is the beginning of all where all numbers start. So now you have 0. When you get to 90, that's the same thing as doing radians. It's like the radians in half, right? So you think of it as like the halfway point. So that's pi over 2 because one whole pi is equal to 180. Okay. So that's all. If you know this right here, that's like all you need to know, because then everything else is just a multiple, right? Because if pi is equal to 180, right? So obviously pi is 3.14, but remember these are like 180 is degrees, pi is radians. So you just have to associate them as the same thing, even though we obviously know that pi is 3.14, right? But for like, and you'll see this like in the future, they mean the same thing in terms of angles, okay? So if pi is 180, obviously that means that 90 is pi over 2 because 180 and half is 90, right? And then 360 has to be also 2 pi because that's double 180. Does that make sense? Does that kind of help? So, and then 270 is just like you add another half. And so obviously 1 plus 1/2 is 3/2. So that's why it's 3/2. And then you add the pi again. So everything is pi. And then you can keep going, right? So if this is 2 pi, which is 360, that's a full circle, right? So now if I told you to do like, um, 200 again, we would rotate all the way around to 200. And then 200 is also going to be, now you can also write it in terms of pi. So if this is 200 degrees, now the way to do that is, well, you have to think, okay, well, so this is kind of intuitive, but you think, okay, if pi is 180, right? Well, if I'm at 200, obviously I'm bigger than 180. By how much though?
20.
By 20 degrees, right? So right now, so let me get rid of some of this here. Yeah, let me just make this a little bit smaller here. Okay, so I have, if I do 180, that's pi, right? I know in degrees it's 200, so all I'm missing is the 20 degrees extra, okay? So if I were to write 200 degrees in terms of radians, I know it's at least pi, but there's this 20 degrees that I don't know. Well, how do I figure out what 20 degrees is in terms of radians, right? We know that 90 degrees is pi over 2, right? Well, so you just kind of use like ratios, right? Well, if 20, so if I have 20 degrees, um, I know all I have to do is say, well, okay, 20 degrees over 180. And this goes back to like when we were doing ratios. I forget when that was, but we were doing like proportions and stuff. Let me write this in a different color. So if 20 degrees is the same to 180, that's the same as something. This is going to be some number x. Yeah, so like, so if I want to write this in radians, well, it's going to be some number x times pi, right? Because radians always has pi in it, right? So it's some number x times pi. That's 20 degrees. And 180 is, how do we write 180 in radians?
Just pi, right?
Just pi, yeah. So this is just same thing as writing those proportions from like several months ago. Because 20 degrees, I know is going to be some number times pi. And I already know that 180 is just pi. And so now I do the proportion. Remember, we can like simplify and cross multiply. So the pi's are going to cancel out. And all that means is that x is going to be 20 divided by 180. So all you have to do is divide. This happens to be 1/9. Now don't forget, x 20 degrees is going to be x times pi. So we have 1/9. So to write it in radians, we have to add what?
Add pi, right?
Add the pi. Yeah, we have to add the pi. So basically, so the whole point of that is literally all you have to do is divide and then add pi at the end, because that's all I did, right? So now that I know that 20 divided by 180 is 1/9, so that means in radians, all 20 degrees is just 1/9 of pi, which is the same as pi over 9. Does that kind of make sense? So like, lo and behold, like even if you don't remember that like whole, like, you know, mechanic, you just divide. Because think of it as like, if one whole pi, you know, is 180, that means like anything less than 180, all I have to do is divide. So 10 degrees, if I divide 10 by 180, that's 1/18 of 180. That means it also has to be 1/18 of pi at the same time, right? Does that help? Okay. All right. So let's just kind of go back. So let me clear this whole thing. So the whole point of that was to say, okay, well, if we graph this differently now, I have 0. This is 90, which is also pi over 2. Oops. Pi over 2. This 180 is pi. 270 is 1.5 pi. So if I were to graph 200 degrees, it's going to end somewhere here. And I know that it's going to be pi. And then I know that 20 degrees is 1/9 of pi. So it's a whole pi plus 1 more 9th of pi. And then this is going to just equal 10 ninths of pi. Because I had 1 whole pi and then I just add 1 more 9th, right? So this is 9 over 9, and then I add 1 more to get 10.
So when we're when we're translating from degrees to radians, we should use fractions instead of like simplest decimals.
Oh yeah, always, because pi is an irrational number, right? So it goes on forever. So you never want to write it as a decimal. Radians always has to have pi in it. So you're always going to have some fraction, which is a rational number, right? You have this part and then pi. That's always what radians looks like. Cool? Cool. So if we go kind of to the homework, right? The first one is pretty similar, because the first one on your homework, well, actually, no, you have to do even. So let's just do number 19. 19 was 240. So that's like somewhere here, right? Then we go past 180, and it's a little bit bigger than 200. Well, actually, 240 is pretty close to 270. So again, we know we have pi because we passed 180. And then all we have is, if this is 240, 240 minus 180, the difference is 60, right? Now, this 60 is kind of important because if you remember from the unit circle, and that's the reason why the unit circle is so important and why like I had you guys just copy it pretty much as like an assignment, just because the more you get used to it, if you memorize things, you'll just be able to do it faster, right? Also, like if you're when you're doing work at home right now, you can just look at the unit circle to help you. So it's not cheating, right? It's the unit circle is there for you to use. 60, if you just look at the unit circle tells you that 60 degrees equals pi over 3. It's 1/3 pi. So we don't even have to calculate for that. Obviously, if you were to calculate, you just divide 60 by 180, which is 1/3. So same thing. Oops. So 60 is pi over 3. So we had pi. To get to 240, we add pi over 3. So this total is going to be 4/3. You add the fractions, right? You add 3 over 3 plus 1 more third, and then you just add the pi at the end. Sorry, I'm not coughing so much. Cool. And again, it's pretty typical. I know I'm writing the pi like on the side here, but just get in the habit eventually of like writing the pi in the numerator. It just looks nicer. It's the same thing, right? So you just put the pi on top. Cool. Sweet. And then going backwards. So going backwards is like a little bit different, but if you think about what we did to go degrees to radians, from degrees to radians, we divided by 180, right? What do you think we're going to do to get from radians to degrees?
Just the opposite.
Which is?
Multiplying.
Multiply, exactly, yeah. So if we multiply by 180, so now I had 1/9 pi. So if I multiply by 180, of course, now that I'm going to degrees, I get rid of the pi, right? And if I'm multiplying, 180 times 1/9 is the same thing as dividing because it's a fraction, but then obviously you get 20 degrees. So that's the cool thing, that it is just opposites, which is really nice because it'll help you remember both, right? So, yeah, so at the end of the day, so degrees to radians, we divide by 180. Divide, it looks ugly. Divide by 180. And then from radians to degrees, you get rid of the pi, of course, and then you multiply by 180. And then don't forget, from degrees to radians, you have to add pi. So I'll put in parentheses here, you have to add the pi. And then when you go back to degrees, of course, you get rid of the pi. And you write your degree symbol. Cool? And that's pretty much the rule you have to follow for all of them. So like the first few ones in your homework, you just follow that rule pretty much. Cool? So that, yeah, I think that does it for that. Any questions on those? Yeah, what's up, Megan?
So on the like number like 28 and 30,
Yeah.
what exactly are, like, we're allowed to use the unit circle for that too, right?
Right, yeah.
Okay. And we can just use the points from the unit circle to like plug in to find like sine and sine.
Yeah. So
Okay.
yeah, so this is kind of what I was saying like before, and what I think I was saying in like last week's lessons is so that was like the first part. So the unit circle now, basically the unit circle, and if you saw this in the book, the unit circle just goes to show that sine, and this is really what I was emphasizing before, sine is equal to y, and cosine is equal to x, and then a tangent, of course, is y divided by x. And so that's exactly what the unit circle is trying to like help you with. Is the unit circle, of course, is when you have a circle that's just like one, right? So the radius is one all around. And so what happens is you can just look at it to help you calculate all these different things. So if we just do 28, so 120, if you look at the unit circle, 120 on the unit circle is at negative 1/2 square root of 3/2, right? And that's awesome because if you're taking the sine, well, we know from right here that the sine is equal to y. That means literally the sine of 120. Like these problems like require no work really, other than just writing down like what you know, because now we know that the sine is equal to y. The y value is square root of 3/2.
Okay, that makes sense.
Yeah. So the whole thing about the unit circle is like this part. Hold on. This is what the unit circle proves. It's good to memorize the unit circle for like lots of different reasons, because like you can convert degrees to radians quickly and all of that stuff. But this is like the whole main point of the unit circle, is that the sine of anything is going to be the y value, and then the cosine of anything is going to be the x. Tangent is y over x. And if you look at the unit circle, it gives you all of the values that you need, I think. Yeah. Cool. Yeah, and then I didn't really realize this before, but problem number 30 makes you do the secant, which is kind of annoying. But remember secant, secant is just equal to the reciprocal of cosine. So we can just do this problem because I didn't realize that it was on there, but it's asking for the secant of pi over 3. So pi over 3 is the same as 60 degrees. But anyway, but the unit circle already labels it as pi over 3, and that point is, if we write it here, it's 1/2 square root of 3/2. So to calculate secant, we need the cosine first, because it's 1 over the cosine. The cosine is the x value, so 1/2. So that means cosine pi over 3 equals 1/2. That means secant equals the reciprocal of 1/2, which of course flipped is just 2. Cool. So that's all the work you have to show for number 30. I would, if I were you, like, I know it's not for homework, but if you just want practice, just to make sure you're understanding, like do number 27 and 29 just like on your own, because I didn't assign those, but those will definitely help you more like figure out what's going on. Okay. And then the last part of the homework, use reference angle. So those, sorry. Okay, so those aren't bad because you just have to find sine, cosine, and tangent, right? Yeah, and then you use the unit circle. Okay, yeah. So the last ones are just the same thing. You're just using the just use the unit circle. The unit circle gives you all the x and y values, and then you just literally have to write all the functions, so sine, cosine, tangent. So that one will require a little bit more work, but again, you just use the unit circle and it gives you all the answers. Cool. And then don't forget negative. That's the other thing I noticed is like, it's the same rules. Okay, so remember how we said like you can go backwards. If we go backwards, this is -90 and -180 and so on, right? It's the same thing for radians. So we know that 90 is pi over 2. So this is just negative pi over 2. This is negative pi, so on and so forth, okay? So don't be tripped up by that. And you follow the same exact rule because remember, to go from radians to degrees, you divide by 180, but now you're just gonna have a negative in there, right? So it's a good example real quick. So like, yeah, so if you did like negative 45 is here, this is negative 45. Well, it's the same thing. You just do negative 45, negative 45 divided by 180 is going to give you negative 1/4. So, and then all you have to do to turn it to radians is add pi. So it's just the same as writing negative pi over 4. So it's the same exact process. You're just going to have negative in front, okay? And obviously it's going to be a different place on the graph, but that doesn't matter so much. Cool. Any other questions? No? All right. How's everyone else doing?
Wait, can we do a problem where we turn the radian to degrees?
Yeah. Do you want it to be negative or positive?
Either one's fine.
Okay. So let's do this one. So I have 7 pi over 2, okay? Which sounds like a lot. So even if you don't, hold on, sorry. Even if you don't know how to graph that, that's okay. So if you just think about it real quick, 7 halves is bigger than 2. So this is actually going to look like a full circle plus some, right? But regardless, to turn it into degrees, we have to multiply by 180. Okay? Because remember, pi is 180. So if we multiply by 180, we'll figure out how many like 180s we have. So if we multiply by 180, the 2 cancels out the 180, so it's really 7 times 90, which equals 630. And then you just add the degree symbol, and that's it. So that's a lot. Cool. Sweet. And then if you do a negative one, so negative, let's say if you have negative, let's do negative, not that, negative 5 pi over 8. Same thing, the negative is just going to stay with you. This is less than 1, right? Because it's 5/8. So we know it's going to be, so that's how you check your work a little bit. 5/8 is less than 1. So we know this is going to be less than 180. So let's just make sure we do it correctly. So if we multiply by 180, yeah, it just depends how you like to do this. I'm just going to multiply it out. So 5, so this is going to be negative 900 divided by 8, which is also negative, sorry, I'm going to do this in my head real quick. 2.5 degrees. Obviously you can use a calculator, right? Like you don't have to do it in your head like I did, but we got rid of the pi, multiplied by 180, and then it turns out that 5/8 of 180 is negative 112.5. And that we check our work. Obviously, that makes sense because we wanted it to be less than 180. So we probably did not make a mistake there. Cool. Sweet. Yeah, that's pretty much it. Yeah. Any other questions? Comments, concerns, thoughts?
Do
Everyone
you
doing it?
think
Yeah.
the quarantine is gonna be lifted soon?
No, definitely not.
Okay.
Yeah, I mean that like scientists are saying like a vaccine won't be ready till next year, like not even early next year. Yeah, so I think a lot of schools are going to try to open and stay open in the fall. Obviously, it's going to be like closed until then, but the thing is like depending on like depending on what happens and where you live, like some people are not going to be comfortable going out. Like you might have to wear masks at school next fall. Like it's just going to be it's going to be different for sure. But I think schools do want to stay open in the fall. It's just without a vaccine, like anyone could still get it, right? So it's like not safe still.
True.
Yeah.
And didn't scientists say that there's gonna be like another wave? I cannot. No.
I mean, that's what they say, but like I think that's what they say, but if we stay isolated for the most part, it won't happen.
Yeah.
The key is just like figuring out like if the key is really just like not to be mean or anything, but the key is just to control stupid people because
Yeah.
the dumb people who like are even somewhat sick, if they don't control themselves and like stay inside, they're the ones that are gonna make like spread it, right? Because
Yeah.
like any of us, if we're healthy, we could go to the grocery store and stuff, but if someone who and it's not always their fault, but if they don't know or like they feel a little bit sick but like need to get something, if they go and you accidentally like walk next to them, you could get sick, right? So I think I think too, if like we get a lot of tests, they're saying too, if we can test a lot better, which will probably happen over the summer, then we might be able to like actually go back to school and all that. Because if we test everyone,
The most dangerous part of this is that it's a virus which can go dormant for periods of time. If it's not successful at infecting someone, it can stay inside their body. Like viruses can do that. People
true,
can
yeah.
get the virus without truly getting sick, and that's the most dangerous thing about it, because they'll
That's
still
true.
go out, like less, of course, because we're in quarantine, but they can still spread it
Yeah,
to
that's
people
true.
who are way more vulnerable than themselves. And
Yeah.
the only way that we can stop it is by having really widespread testing and
Yeah.
hopefully eventually find a cure or a vaccine.
Yeah.
That's really the only way.
Yeah, I agree. Yeah, we just need to test people. So I mean, they're saying that it'll hopefully happen like over the summer, and then like I said, schools can start to make plans to open and stuff. But it won't be normal. Like I think that's just the reality. It's not going to be normal. They might have to like, I don't know what they're going to do. Maybe like make classes smaller, or I don't know. Everyone will
Oh
wear
my
a mask.
God.
Yeah.
What if like in the fall, like what if we went back but only had like 3 days of school a week,
Yeah.
and then like the other days, like every other day or something?
I mean, that could well happen.
Yeah.
I'm just starting to realize the massive scope of all of this, because it's already gone on for months,
Yeah.
and there's no cure. We don't have a cure or vaccine, so it could still go on for a long time.
Yeah.
Wait,
Yeah.
aren't people that survive donating their plasma or something?
Yeah, I think so. Yeah. I
Isn't
mean,
Tom Hanks? Didn't he? Or
Yes.
who
Oh
got
my
it?
God.
Yeah, but again, yeah, you just have to yeah, if you get tested and like you'd find out. But so that's the thing. If we can test more, we'll find out who can donate and who can do all that stuff, you know.
Not kidding. I think my friend is a survivor because she was
Really?
telling us, yes, she was telling us that like she like thought she had like strep throat or something and she was like, I'm literally about to die. And like she was joking obviously. And this was like a little bit before like or this was like before we were in quarantine, I think. But it was like so crazy because she's like, I think I had it and
Oh wow.
yeah.
It's possible because, you know, again, like a lot of people are also surviving okay when they get it. So, but if you don't get tested, you might not ever know if you had it, you know. What's up, Jack?
Hello.
Hey, what's up? You kind of missed everything, but like I'm happy to like help you if you want to stay.
Okay.
Um,
Did you just show up or did you just put your camera on?
no, Jack he just entered.
I was in my English Zoom call.
Yeah, yeah.
Sorry.
No, you're good, dude. You're good. I assumed that like different classes were supposed to have different times so that we wouldn't like mesh, but apparently that's not what happened. So I'm sorry.
It's fine.
But anyway, yeah, Jack, I mean, if you have any questions, I'll help you if anyone else wants to hang around, but or if you have any other questions, like I'm here for the next 26 minutes. What's up, Megan?
So I copied down my unit circle and I didn't send it to you yesterday, so can I send it to you today?
Yeah, totally fine. Totally.
Okay, thank you.
No worries. Yep.
Bye, Mr. A.
Bye, Megan. Have a good one.
Thank you, you too.
Thank you. Jack, do you need like help with anything? What's up, Ben?
I'm Mr. A.
Jack, you need anything? You have any questions?
I don't know. I copied down the unit
Yeah.
circle last night, and I was just kind of like confused on what it does.
All
Like,
right. So
Oh,
so
it
let
like
me,
transforms from one unit to the other. It just helps you like have a visual that you can
yeah.
turn into one without using electronics.
Yeah. So it's kind of a cheat sheet, Jack. So you saw how it pretty much shows you that like 30 degrees is the same thing as pi over 6,
uh-huh.
right? So did you watch the Khan Academy too?
From yesterday?
Yeah.
Yeah.
Cool. So the whole point of this chapter is like we have a new unit. So we were using degrees and now we have this thing called radians.
Mm-hmm.
So this is like my crash course. So radians, it's just like another unit, right? So it's like saying centimeters versus inches, right? Radians, the only thing that's weird about radians is you always have to have pi in it. Okay.
Okay.
So if you see pi and you're talking about like angles or whatever, that means you know it's radians. So this is kind of like this is basically, without me explaining too much, what you need to know. If I want to go from degrees, so you might have gotten this part already, but if I go to from degrees to radians, all you have to do is multiply by, or sorry, not multiply. All you have to do is divide by 180. Okay. That's all you have to do. So if I have 20 degrees, I want to turn it to radians, I'm divide by 180.
Okay.
And then of course, like I said, radians always has pi. So the only thing you have to do is you add pi to it. Okay.
Okay.
Does that make sense?
Mm-hmm.
So like I said, 20 divided by 180 is 1/9. So then all I have to do is add pi. So I can put on the top.
Does it matter if it's in the numerator or denominator?
Well, it has to be in the numerator because it's like in the denominator means that you're dividing by pi, which that's not what we want to do. It's like in the
Okay.
numerator because it's always there. It's just always there, right?
Okay.
Yeah, so it's in the numerator. And then going backwards, if I want to go from radians to degrees, what do you think we do?
You multiply by 180.
Exactly. It's like that intuitive. You literally just multiply 180, and then in radians we had pi, but in degrees we don't have pi. So all you do is get rid of the pi that you had. Cool.
Okay.
So if like we go backwards, right? Pi 1/9 pi. Well, if we multiply by 180, that gives
Close
us
to
20. And then we just get rid of the pi, and then we just add our degree symbol.
But like, this is where math is annoying to me because I don't like how you can just like, okay, we're done with the pi. Like,
Well, so because so I get you. The real so this is my shortcut formula. The real formula is like you actually have to multiply by 180 over pi.
oh,
Yeah. Because that's like unit conversion. That kind of has to do with science. So that's the only annoying part about this section is like it uses a lot of like science and units and stuff.
mhm.
So yeah, the real formula is you're multiplying by 180 over pi radians. So that's why, yeah. But I'm just trying to shortcut it by just saying like what, like instead of writing 180 over pi all the time, just get rid of the pi because it's going to get rid of itself anyway.
Yeah.
Yeah.
Gotcha.
So this is like, that's like the first part. And then the whole point of the unit circle, this is literally the whole point of the unit circle. And so you can actually write this. So you copied the unit circle for your, in your notes. I would also copy this down, which is the whole point of the unit circle. It's just trying to show you that if you take the sign of anything, it's always going to equal the y value. Okay. If I take the cosine of anything, it's always going to equal the x value.
Mhm.
And if I take the tangent of anything, it's always going to equal y over x, which I was kind of saying like last week, but the unit circle really proves that. Okay.
Mhm.
So that's the whole thing. So if you look at the unit circle, right, it gives you all of these like degrees and radians, and then it gives you the points, right?
Mhm.
So if we use this knowledge, let me just write it smaller. So sine equals x or y, cosine equals x, tangent equals y over x. So if you look at the unit circle, it says that, let's say I wanted to do 60 degrees. 60 degrees is also the same as pi over 3, it says. Okay, so if you see either, they're the same thing. It says that the point for 60 or pi over 3 is 1/2 comma square root of 3 over 2. Cool?
Mhm.
So now we can answer all of the three functions because remember it's x and y. So that means the sine of 60 equals what?
Sine of equals 60y.
No, it equals the y value. So what's the y value
Oh.
here?
Oh, 1/2. Or no, negative. Or sorry, 3 the square root of 3 over 2.
Exactly. You got it.
Okay.
Yeah. So that's literally the answer. So that's the whole point of the unit circle is you can it's basically it is actually like a cheat sheet and like a shortcut.
Okay.
Because now instead of like, you know how like a couple weeks ago we were doing all this stuff to calculate sine, like you had to go like opposite, hypotenuse, and like do all this division.
Mhm.
Now with the unit circle, if you get one of these like degrees or radians, you can literally use it as a cheat sheet. And so sine of 60 is square root of 3 over 2. The cosine is equal to what?
1/2.
1/2. And then the tangent, this one's a little bit more complicated because we have to divide. Let me write this off to the side. So square root of 3 over 2. If you divide it by 1/2, it's the same thing as saying, that's the same thing as just writing it as like square root over 3 over 2 times 2 over 1. So this cancels out. So that just means the tangent is square root of 3. So that you can use your calculator, like, or just, show work for that one. But,
Okay.
So the whole point of the unit circle is we were able to calculate sine, cosine, tangent in just like a few minutes.
Awesome.
And again, you do that with anything. So for your homework, you'll see they'll give you like all of these ones that are labeled that you labeled on your notebook. Okay.
Okay. Is it
And
okay
just-
if I take a picture of that?
Yeah. Oh yeah. Go ahead.
Okay. Awesome. All right,
Yeah.
thank
So
you.
yeah, no problem. And remember, it all comes down to like the points that they label. Okay. That's where you get your X and Y.
Okay.
Does that help?
Yeah, awesome. Thank
Sweet,
you so
man.
much.
Yeah. Just let me know if you have any other trouble. Just email me or something.
Okay,
All right.
thank you.
Yep. Good luck, buddy.